800 kilometers per hour in 5.3 seconds. This Maglev vehicle crossed 1 kilometer of track. Hidden in central China, this test line was built for exactly one purpose.
Flat, precisely engineered to millimeter tolerance, this corridor had to be perfect. At these speeds, even air itself becomes an engineering project. No wheels, no rails, just magnets lifting a vehicle off the ground. Look closely. There's no groove, no rail, nothing for wheels to grip. That gap between vehicle and track is the entire secret. Permanent magnets and electromagnetic propulsion, together, they replace every moving mechanical part. 0 to 100 kilometers per hour in under 0.7 seconds. Faster than most jets.
At the 600-meter mark, this vehicle is already at full speed. Then comes the hard part, stopping safely in the 400 meters left. What looks calm on the outside hides 3 overlapping engineering problems. At 800 kilometers per hour, airflow separation alone can destabilize the entire vehicle. Every relay along this track talks to the vehicle in real time. Each motor segment fires in exact sequence, precisely timed to the vehicle's position. Together, these systems form one integrated machine, stretched across a kilometer. Behind every run, a small team reviews the data by hand. This wasn't a single leap. It took 3 separate world records. June 16th, the platform hit 650 kilometers per hour for the first time. Weeks later, engineers return with upgraded sensors, chasing an even higher number. July 14th, 700 kilometers per hour, a new record, just 1 month in. 2 records down. One far bigger target still waiting ahead. Every run adds data. Every data set sharpens the next attempt. By November, the vehicle carries its most refined configuration yet. This time, the target isn't 700, it's 800 kilometers per hour. Every propulsion segment fires in tighter sync than ever before it. Speed builds fast, faster than either record attempt before it. At 600 meters, the vehicle crosses 800 kilometers per hour, a new world record. 8 seconds total, then a controlled stop, exactly as planned. Hitting the number was the easy part. Proving it was safe wasn't. For a month, engineers recheck the levitation gap for any drift. Every speed increment gets tested for precision, not just raw power. Slower passes now, cycle after cycle, checking the system won't fail. A month of quiet testing behind one headline-grabbing 8-second run. Only after that month does the lab go public with the number. The record was never really the point. This corridor is a research platform. The same infrastructure that set a record could test dozens of future ideas. One proposed use, electromagnetic launch assistance for spacecraft leaving the ground. Not every run chases a record. Some simply demonstrate the platform's range. A kilometer of track, built to answer questions far beyond one record. The next test is already being prepared before this one even airs. But a passenger version needs something this test track doesn't have. Length. 1 kilometer
proved the physics, a real route needs hundreds more. Maglev infrastructure demands near-perfect alignment, a standard conventional rail was never built for. Sensors along the guideway check structural integrity after every single run. Safety verification isn't a footnote here. It's built into every test. The lab says safety research is as central as the speed record itself. One final check at the console. Then, the day's testing is confirmed complete. A single command from the console, and the guideway responds instantly. One tap logs the record permanently into the lab's dataset. Then, in sequence, the entire propulsion system powers back down. For now, the corridor goes quiet until the next scheduled test. In late light, this test track looks less like a lab, more like art. A single straight line cut across an otherwise unremarkable stretch of Hubei. Every magnet segment here was machined to a tolerance most industries never need. As daylight fades, the vehicle that broke a world record sits perfectly still. Not every record needs noise. This one ends in complete silence. Right now, this is a research platform, not yet a passenger system. What happens here could eventually shape how we all travel, someday. For now, it's just a kilometer of track and a machine that proved something possible.